Hello to all the future mathematicians. I recently decided that I wanted to learn how to make computer games, and in particular mathematically based computer games, and the thing that you see rotating behind me, this is just it. This is the game that I'm working on. So in this game you get a polyhedron, which is just a combination of faces and edges, and you need to cut along the edges until you can unfold it on the table. So for example, in this case this is a dodecahedron, and when you unfold it, it looks like that. So already here there are interesting mathematical ideas that I came upon. For example, you start with a single polyhedron and you can ask what sort of unfoldings does it have, or maybe you want to attack it from the other way around. You want to construct such a game, and you can ask what sort of algorithms do we need to construct these polyhedrons or to make this unfolding. So at this point I had several ideas and I wanted to actually make some videos about them, but before that, originally I really wanted to learn how to make computer games. So I decided before the videos I want to create this polyhedron and make it a little bit prettier. So what do I mean by that? Let's stop the rotating. So right now this polyhedron has this pink orangey color and I wanted to look a little bit better. So I went online and downloaded some textures and began to add them to the polyhedron. And as you can see, something happens but not exactly what we wanted to happen. And here I had this new problem. What exactly is broken? How do I fix it? And as a bonus, what is the connection to mathematics? So before we get to the mathematics, we first need to ask, how does the computer add textures to some objects? Okay, so now we have the texture above me, and I want to take it and put it on a triangle on the left. However, we see the same problem as before. Instead of seeing here the texture, I only see a black triangle. So what really happened here? Well, the computer knows it needs to take the texture to the triangle, but if you give it a single point on the triangle, it doesn't know what is the point of the texture it corresponds to. So because we didn't tell it what to do, it uses the default implementation and just sends all the point here to the same point on the texture. And in this case, it moves all the point to this blue point. And you can see if I move it around, it changes all the colors on the triangle. So how to fix it? Well, we need to tell the computer where to take this blue vertex, where to take this red vertex, and where to take this green vertex, and it will do an interpolation for the rest of the points. So for example, let's move just this blue vertex, and we can already see a nice pattern here. Well, there is something changing between the blue to the green-red edge, but between the green and the red we see exactly the same, because still the green and the red points go to the same place. So if I also move the green point, then now we see a texture on the triangle in the right way. Okay, so this was basically the problem with my code. I told the computer which texture to use, but not how to use it. However, there is still an interesting problem which we have yet to solve. I still need to tell to the computer where exactly are these 3 points. Well, right now the texture looks fine, but if I move, for example, this green point over here, then suddenly it looks very, very strange. So what is this property? What do we need to tell the map from left to right so that the texture would look fine? So for example, if we move to the previous case, then now it looks fine, and we can ask what is the nice properties that we have. And I would claim that, notice that the triangle on the left and the triangle on the right look more or less the same. Right? The map from left to the right more or less preserve the size of the edges and the angles between them. So it is a distance preserving map. Now this is a very, very nice mathematical object. It is called an isometry. And basically whenever you have this isometry, you have this distance preserving map, then the texture on the right and the texture on the left will look very, very similar. So this is what we look for. However, right now we're only on the 2-dimensional case, so this is very easy to do. Just take the triangle from the left and move it to the right until you get a triangle over here. However, when you get to the 3-dimensional case, there is something interesting, so let's move there. And you can see that if I move just one point on a triangle, now it lives in the 3-dimensional world, then this triangle is stretched, however these points remain in the same place. So the texture doesn't really fit the size of the triangle here. This map from here to here is not a distance preserving map. And this is the interesting problem. You have a triangle in the 3D place, in the 3D world, and the question is, how do you define a distance preserving map from a 3D world to the 2D texture? Okay, so now our problem is to take the triangle on the left, which you should think live in the 3-dimensional world, and map it in the distance preserving way to the 2-dimensional world where the texture is. So to describe a triangle, let's assume that you have the origin somewhere here, and the 3 vertices which describes it, let's call it U0, U1, and U2. So these 3 vectors live in the 3-dimensional world. However, the triangle should be a 2-dimensional object. So let's describe it as a 2-dimensional object by looking on these 2 vectors. And let's call it V1 and V2. So V1 is U1 minus U0, and V2 is U2 minus U0. Okay, so now we have just 2 vectors instead of 3 vectors. So let's remove the UI vectors. Excellent. So now we are already in a much better place. We have only 2 vectors instead of 3 vectors, but you should keep in mind that these 2 vectors still live in a 3-dimensional world. Okay, so now our problem is to say, you give me a point on a triangle, and I need some map which takes this point to some point on the texture. And the question is, how do we do it? Well, we learned about such a method in the first course in linear algebra, which is a very, very simple way, which says the following. If you have a point on the triangle, you should think about it as some move along the V2 direction and move along the V1 direction. So for example, this point V, I can say that it is alpha times V1 plus beta times V2, and then I can map it to alpha beta. So alpha beta is a 2-dimensional vector which I got from the 3-dimensional vector V. So for example, right now you can think about V as like half times V2 plus half times V1. However, we have this map, but is it distance preserving? So let's see a couple of examples. If I take V1, I can write it as 1 times V1 plus 0 times V2, and I can write V2 as 0 times V1 plus 1 times V2. So if I map these 2 vectors, I get 1, 0 and 0, 1, so I get these 2 vectors. So notice that I started with some general 2 edges, and I always end up with 2 edges of length 1, because it is 1, 0 and 0, 1, and they have 90 degrees between them. So this is not a really distance preserving, angle preserving map. It's just some general map. So if we really want to do something which is distance preserving, I need to somehow start with 2 vectors which has size 1 and has 90 degrees between them. And if I can do that, then this map will be distance preserving. So let's try to fix this process. Okay, so instead of taking V1 and V2 as they are, let's start in V1 and move it in a parallel way to V2 until we get a new vector which has 90 degrees. So this is already better, because if we start with this vector in V2, then we have 2 vectors which have 90 degrees, the same as we expect. Moreover, we want them to be on size 1, so let's say that this is a size 1, and let's say that this is size 1, and call this one V1 hat, and this V2 hat. And now I can do exactly that I did before. Instead of writing V as a combination of V1 and V2, I will write it as a combination of V1 hat and V2 hat. And now if you take alpha and beta, and if you move V2 alpha beta, then this is actually going to be a distance preserving map. Moreover, there is a very simple way of computing alpha and beta. So alpha is just a scalar product of V times V1, and beta is the scalar product of V times V2. So not only we found a nice basis for the triangle where we can do this distance preserving map, we can also very easily compute this alpha beta. So this new and interesting concept of 2 vectors which are perpendicular to one another and a size 1 are called orthonormal sets. And in general, starting with a general basis and move it into an orthonormal set, this is a very simple process called the Gram-Schmidt process. And it is very, very easy. Basically, what we did here is most of the process. It is, again, it's technical, but very easy. So if you really want to learn more about it, then I will add some links in the description. Okay, so now that we know what is the mathematics that we need in order to solve the texture problem, let's return to the polyhedron and see how it looks like. Finally, we are back with our polyhedrons, and I fixed the bugs in the code using these orthonormal sets in this Gram-Schmidt process, and you can see that the textures now works fine. Okay, so I hope that I managed to interest you a little bit in mathematics or in the mathematics of game development, and I will see you next time in other videos, hopefully with some textures on my polyhedrons.